Okay, so this is what we want to do. We want to go to, well, before we even do this, we just want to set up our experiment. That's going to be the very next thing that we're going to do. So how do we begin? We're going to begin like we always do. We're going to go to Moodle Mobile. I'm going to select on Moodle Mobile, and I'm going to go to the video that was downloaded earlier. And instead of us doing the first one, I'm just going to go ahead and do the second one, this updated video. Okay, I'm going to select on that, and then I'm going to open the file. And once I open the file, I'm going to go ahead and share this with Video Physics. So it shouldn't take long at all once it's shared, and you'll see that it's coming in as Experiment 6. So of course, I want to go back and I'm going to change the name of that. I'm going to call this Predicting the Range. Predicting the Range, Brass, Eric. So I'll probably put Brass E, just because I've done this somewhere down the way. So let's go into the video. And the first thing that we want to do is make sure we calibrate this. So let's look at this first. I'm just going to play this. Notice how I have some things going on in the beginning, and then I go about shooting these balls. Okay, so we're going to go back to the beginning, and you'll notice that in the beginning we don't want to use these values. Okay, this is just merely measuring with more precision. So you can see that we have 13, I think that's 13.063 millimeters. So that's allowing us to get down to our microns. And you'll notice that the angle is close to 20, but it's not quite 20. So this is going to introduce some error. So we might need to compensate for that when doing this experiment. At one time I did want to delete it, but now I don't. So we're going to start right here. We can pick a lighter version if we want to. We're going to start right here. We're going to set our origin and scale. So where's the origin going to go? Well, it's going to go exactly where we put it last time. And let's choose the center of this launch position. And let's set our scale anywhere along this rod. So I'm just going to choose 20 centimeters this time. So I'm going to go between 40, that's my initial position, and 60, that's my final position. Our final minus our initial will give us 20 centimeters. So converting that over to meters, that's 0.2 meters. I'm going to double click. The name is here, all right, and that is good. And we have everything calibrated and scaled. So now I'm just going to take a snapshot. Okay. Once I take that snapshot, I want to describe the theory or connect this to the theory that we presented earlier. And you can see it here. So I'm just going to produce a new page. And I am going to bring this picture in to Paper by 53. It is really nice. And then I'm just going to draw on this picture. So you guys pretty much know what's going to happen. The ball is going to be launched right here. Let me see, I don't want to use that pen. The ball is going to be launched right here with some initial velocity. Part of that initial velocity is going to be in the X. Part of it is going to be in the Y. So we have our Y initial here. We have our X initial right here. Let's see if I can make this big. I think I can. So we have our, go back, X initial right here. And we know that this is just the initial velocity times sine of the launch angle. And this is just the initial velocity times cosine of the launch angle. So this position right here is our X initial and our Y initial. And when the ball is launched, let me see, I wish I had that picture, but the ball is going to go out and it's going to land maybe right in this position here. And this is going to be our X final and our Y final. That's what this position represents. So now if we write our kinematic equations, the ones that will allow us to predict the range is XF minus X initial equals to V initial cosine times the time of flight. Oh, cosine of the angle. Theta, or the launch angle, times the time of flight. And how are we going to calculate our time of flight? You guys may or may not remember, but we're going to use the Y equation. YF minus Y initial equals to our initial velocity times sine of the angle times t minus 1/2 gt squared. And you know we just used the quadratic formula to solve that. That was a negative b, plus or minus. And in our case, we don't need plus, we just need minus. If you worked out the theory, you would see it. So this is b squared minus 4ac all over 2a. So that's how we're going to work all of that out. That's the theory connected directly to a real experiment. And we're just going to use Microsoft Excel to produce these calculations for us. All right. So I'm just going to say done with that. And let's go back to predicting the range. And the next thing we want to do is plot our points. And I'll do that in the next video.